Okay, okay, this is lesson 5.4, and it's covering chapter 10.4 of the textbook. The title is The Algebra of Matrices. Really, I think a better title would be The Arithmetic of Matrices. What we're doing in this section is the basic arithmetic operations of two matrices. We're going to add two matrices, subtract two matrices, multiply matrices, that sort of thing. So first thing we're going to talk about is how to add or subtract two matrices. We're going to talk about what's called scalar multiplication. And then we're going to talk about how to multiply two matrices. So starting with addition and subtraction, it's pretty easy. Add or subtract in order to add or subtract two matrices, first thing you got to make sure of is the two matrices must have the same dimensions. In order to add or subtract two matrices, they have to have the same number of rows and columns. They have to have the same dimensions. And if they do match, if they have the same dimensions, then you either add or subtract the corresponding entries. So for example 1, if we have this matrix now, this has 3 rows, 2 columns. So this is a 3 by 2 matrix. And the only other matrix we can add this to is another 3 by 2 matrix. So something like this. These two matrices have the same dimension. This one on the left is a 3 by 2 matrix. This one on the right is a 3 by 2 matrix. If you add two matrices together that have the same dimension, you're going to end up with a matrix of the same dimension. So we're going to end up with a 3 by 2 matrix. And in order to figure out the entries of this matrix, you add the entries in the corresponding spots of the two matrices. So here we have a 1. We add that to this -4. To get -3. Here you take -2, add it to the 10 to get 8. 6 plus 7 is 13, and so on. 4 plus 4 is 8. 7 times 2, or 7 plus 2 rather, is 9. And then 9 plus this 11 is 20. Okay, and the same thing goes for subtracting matrices. We had this matrix here, and we wanted to subtract. That matrix there. Now this matrix on the left has 2 rows and 3 columns, so this is a 2 by 3. Same with this one, this is a 2 by 3 matrix. So since they have equal dimensions, we can subtract them. By subtracting the two, we're going to end up with another 2 by 3 matrix. And you just subtract the entries in the corresponding spots. So 1 minus 6 is negative 5. 2 minus 5 is negative 3. And then 3 minus 4 is negative 1. 4 minus 3 is 1. 5 minus 2 is 3. 6 minus 1 is 5. That's really about all there is to adding or subtracting two matrices. You just got to make sure that they have the same dimensions, and if they do, you add or subtract entries that are in corresponding locations. So next topic is what's called scalar multiplication. The scalar is just a fancy name for a constant, a number that has a value. That's what's called a scalar. So we're not actually, scalar multiplication doesn't refer to multiplying two matrices together. It refers to having one matrix and multiplying it by a scalar or a number. So a scalar is a non-zero number. So for example, 2 quite often when dealing with matrices, especially if you're dealing with large matrices or multiple matrices, matrices will be given names. Like this could be the matrix A. So find 2 times A. Well, what this means is take the matrix A, which is this matrix here, this 3 by 3 matrix, multiply it by 2. How do you multiply a matrix by 2? Well, 2 in this case would be the scalar. So if you imagine 2 times that entire matrix, all you would do is multiply every single entry in that matrix by that scalar. So if A equals this 3 by 3 matrix, then 2A, it doesn't change the dimension or the size of that matrix. It multiplies each entry of the matrix by 2. So it's going to be negative 2, 6, negative 14, 4, 0, 16, negative 8, 12, and 4. Now what's going to be more common on your homework is to combine these two or these three operations: addition, subtraction, and scalar multiplication. So for example 3, let's define a couple of matrices here. Matrix A is 2, 0, 7, negative 3, 5, and negative 1/2. Matrix B is 1, negative 3, 2, and 0, 1, 2. Matrix C, 7, 0, negative 3, 1, and 0, 5. And then matrix D, 6, 8, 0, 1, negative 6, and 9. So 4 matrices here. Matrix A and B are 3 by 2 matrices. C and D are 2 by 3 matrices. So task A, or part A, you can find A plus 2B. Okay, well, nothing's happening with matrix A. We're not multiplying it by a scalar, so the entries of A stay the same. 2, 0, 7, negative 3, 5, negative 1 half. We're going to add that to 2 times the matrix B. So every entry in matrix B gets multiplied by 2, so it becomes 2, negative 6, 4, 0, 2, 4. Both these matrices still have the same dimension. This is a 3 by 2. This here is a 3 by 2. So they can be added together to form a new matrix. 4, negative 6, 11, negative 3, 7, and negative 1 half plus 4 is 3.5, or 7 halves. Part B, let's do 3C minus D. So shouldn't take you very long. Once you go ahead and write it down and give it a try. So 3 times the matrix C is going to be 21, 0, negative 9, 3, 0, 15. And then we subtract matrix D. And with something like this, you just really got to pay attention to your arithmetic. 21 minus 6, and just pay attention to minus signs, minusing negatives, and that sort of thing. But 21 minus 6 is 15. 0 minus 8 is negative 8. Here, negative 9 minus 0 is negative 9. 3 minus 1 is 2. 0 minus negative 6 is 6, and 15 minus 9 is 6. So those are some of the basic operations. Addition, subtraction, scalar multiplication. Just a few important properties. Of addition and scalar multiplication. So let A, B, and C be M by N matrices. So they all have the same dimension, M by N. And let C and D be scalars then these properties are true. A plus B is equal to B plus A. That's called the commutative property. Another property is A plus B in parentheses plus matrix C is equal to A plus B plus C in parentheses. That's called the associative property related to matrix addition. Another property here, very much related to this one, the associative property. This is an associative property of scalar multiplication. If you have C times another scalar D times a matrix A, that's the same as multiplying C times D first and then multiplying that by A. Another one, the two scalars C plus D multiplied by the matrix A. This is a distributive property. This is C times A plus D times A. And similarly, a scalar C multiplied by the quantity matrix A plus B is equal to CA plus CB. Now the next objective is multiplying matrices, and it's not what you think. Matrix addition, subtraction, scalar multiplication, it's pretty straightforward. They have to have the same dimensions. You add, subtract corresponding entries, or with scalar multiplication you just multiply every entry of that matrix by the scalar. But matrix multiplication of two matrices, it's quite different. It's not what you would think. And there's one thing you have to understand: matrix multiplication, the way that it's done, the process that it's done is simply by definition. It's not that it inherently has to be done this way, or that it was discovered to be done this way. It was invented to be done this way to serve particular purposes. I know when you see the process, it doesn't seem like there's much rhyme or reason to it, but it needed to be done this way to serve the purpose for which it was invented. So let's just get into it. Matrix multiplication. In order to multiply matrix A by matrix B, matrix B must have the same number of rows as the number of columns of matrix A. So it's not that they have to have the exact same dimensions, but the number of rows in matrix B has to be the same as the number of columns in matrix A. So for example, let's say matrix A is an M by N matrix. Matrix B could be an N by K matrix. So this is the number of columns. This right here is the number of rows. since they're the same, the number of columns in matrix A is the same as the number of rows in matrix B. Since those are the same, those two matrices can be multiplied. Okay. And the other interesting thing, the product A times B, it is possible because the columns in A are the same as the rows of B, and will result in an M by K matrix. So you look at these inner dimensions here, the rows and the columns here. If those match, that tells you the matrix multiplication is possible. But the outer dimensions here, the M and the K, those tell you the dimensions of what the result is going to be, the product. So you need to pay attention to all of that. Now let's go over how this works. What example here? Example 4. So let's let A equal 1, -1, 3, 0, and B is going to equal -1, 0, 5, 4, 2, 7. Now find A times B if it's possible. Well, matrix A is a 2 by 2. It has 2 rows, 2 columns. Matrix B has 2 rows and 3 columns. So checking these inner dimensions here, matrix A has 2 columns, matrix B has 2 rows. So that tells us the multiplication is possible. The outer dimensions here of a 2 and a 3 tells us that our answer, or the product of A times B, is going to be a 2 by 3 matrix. So, try to go through this real slow. It's just something you got to practice doing. It's not hard to do, it's just you have to remember the steps and what order and what goes where. So matrix A multiplied with matrix B is going to result in another matrix that has dimensions of 2 rows and 3 columns. Now, I'm going to really make this a big matrix. If it has 2 rows and 3 columns, then it has 6 entries. So that makes the first column, there's the second column, and there's the third column. These lines just represent the blank entries that we don't know yet. Now, to find a particular entry in this matrix that's going to be the product of AB, we have to determine what position that entry is in the particular matrix. For example, this entry right here, where I put the red star, this is in the second row, and it's also in the second column. So down here we have the second row and the second column. So to figure out this entry right here, we have to consider the second row of matrix A and the second column of matrix B. So we have this row right here, and we have that column right there. Why are we choosing the second row and the second column? Because that's the entry that we're looking for in this product here, is the second row, second column. Now this is what's called an inner product of 2 matrices. This -1 multiplies with -5. Sorry, this -1 multiplies with +5 to make -5. Then you go across the row, down the column, that leads you to 0 and 4. Those multiply together to make 0. And you add those together. That becomes the entry in that particular spot of the matrix. That's called the inner product. So if we wanted to find another one, this one up here, for example, this is in the first row, but it's in the third column now. So we need to go to first row, third column. So this row right here, we have a 1 and a 3. This column, we have a 2 and a 7. Right here and right here. So if we started the first entry of that row and the first entry of that column, we multiply those two. 1 times 2 is 2. We add that now. Now move across to 3, and you move down to 7. 3 times 7 is 21. And that's how we find that entry there. This entry right here, this is from second row, third column. So we need to go to the second row here and the third column. So -1 is the first entry in that row, 2 is the first entry in that column. So -1 times 2 is -2, and then move across the column, down the row, 0 times 7 is 0. So we're going to add 0. And I know this just seems like a bunch of random adding and subtracting and choosing random rows and columns, and it's not random. It was designed this way to serve the purpose that it needed to be developed for, which if we have time we can get to, probably not in this lesson. But it's just a process you have to go through carefully. If you try to do it in your head, or if you try to go through it too quickly, you will make simple arithmetic errors. So you just got to be careful and not try to rush through it. You just got to figure out what entry you're looking for, and then find the corresponding row and column in the matrix, in the other two matrices. For example, this one here. This is in the second row, first column. So we need second row, first column right here. And we're just multiplying and adding corresponding entries. So this is -1 and that -1 multiply together to make 1. And 0 times 0 is 0, so we add 0. This entry right here, this is in, it's getting a little messy here. This entry is in the first row, second column, so we need first row here and the second column there. 1 is the first entry of the row, 5 is the first entry of the column, so 1 times 5 is 5, and we add that, move across the row, down the column, 3 times 4 is 12. And finally, this entry right here is row 1, column 1. So we need row 1, column 1. 1 times -1 is -1. We add that to move across the row, down the column. 3 times 0 is 0. So the resulting matrix, that's the product of A and B, is -1, 1, 17, -5, 23, and -2. Try another one here, just to make sure. Okay, so multiply. If if matrix A and matrix B going to find A times B, if possible. So I always need to check. Just because you're asked to multiply two matrices doesn't mean that you can. You always have to check that according to definition it's going to be possible. And matrix A has to have the same number of columns as the rows of matrix B. So matrix A is a 2 by 3 matrix. Matrix B is a 3 by 2 matrix. If you check these inner dimensions here, they match, so the matrix multiplication is going to be defined. The outer dimensions tell you that the product of A times B is going to result in a 2 by 2 matrix. So, matrix A here multiplied by matrix B is going to result in a 2 by 2 matrix. Now a 2 by 2 matrix has 4 entries. So depending on which entry you want to find, you need to find that corresponding row and column. So let's just go in order this time. If we want to find this first entry, it's in the first row here in the first column. A little bit more to keep track of, so just be careful with your arithmetic. Negative 2 times 1 is negative 2. We add that, now move across the row, down the column. 4 times negative 2 is negative 8. Now move across the row, down the column. 6 times 3 is 18. Now the entry just beneath it is in the second row, first column. Second row, first column. Move across the row, down the column. Multiply the numbers together, get the product, add it to the next product, and add that to the next product. So 1 times 1 is 1. We add that to the next product, which is 3 times negative 2. It's negative 6. Add that to the next product, which is 5 times 3. Add that to 15. Now moving over here to this entry, it's the first row, second column. First row, second column here. Negative 2 times negative 4 is 8. Move across the row, down the column. 4 times 5 is 20. Across the row, down the column. 6 times negative 6 is negative 36. And finally, this last entry here is the second row, second column. Second row, second column. 1 times negative 4 is negative 4. 3 times 5 is 15. 5 times negative 6 is negative 30. So just being, again, as careful as you can. Remember, this all needs to be done without a calculator. Negative 2 plus negative 8 is negative 10. Negative 10 plus 18 is 8. 1 plus negative 6 is negative 5. Negative 5 plus 15 is 10. This one down here at the bottom, the second row, second column, 15 minus 30, that's negative 15 minus 4, that's negative 19. Here 20 minus 36, that's negative 16. Negative 16 combined with 8 is negative 8. Now, using the same matrix, if I turn around and say, okay, find B times A. Well, matrix B was a 3 by 2. Matrix A was a 2 by 3. Inner dimensions match, So it's possible, but take a look at the outer dimensions. It's a 3 by 3. We're taking the same two matrices, multiplying them in just a different order. We're going to end up with a completely different matrix. So we need to make a note of this. Matrix multiplication is not commutative. What that means is A times B doesn't necessarily have to equal B times A. And that's about it for this lesson. Pretty easy, just the arithmetic, some simple arithmetic of matrices.